For thousands of years, we've looked up at the night sky and wondered, are we alone? Now, in 2025, that question isn't just philosophy, it's science. Every month, new worlds are discovered. Planets orbiting distant suns, some blazing hot, some frozen dark, and a few that might just be like home. Today, we stand on the edge of one of humanity's greatest discoveries, finding life beyond Earth. This is the story of how we're searching for it, and how close we might be to finding it. What are exoplanets? An exoplanet is simply a planet that orbits another star. The first confirmed one was discovered in 1995, around a sun-like star called 51 Pegasi. Back then, it was revolutionary. Today, we've found over 5,600 confirmed exoplanets, with thousands more waiting for verification. They come in every shape and size: hot Jupiters, gas giants orbiting so close to their stars that their years last only a few days, ice worlds, frozen spheres orbiting faint red dwarfs, and Earth-like planets, small, rocky, and possibly covered in oceans. Each new discovery pushes the boundaries of what we thought was possible, and reminds us how diverse the universe truly is. The Golden Zone. Not every planet can host life. For that, it must lie in a very special place, the habitable zone. This is the distance from a star where temperatures are just right for liquid water to exist. Too close, and oceans boil away. Too far, and everything freezes solid. Earth sits perfectly in this Goldilocks zone, and scientists are searching for other worlds that do too. Planets that could have the same balance of warmth, light, and atmosphere that made life possible here. But being in the habitable zone doesn't guarantee habitability. It's just the first clue in a much larger cosmic puzzle. Tools of discovery. Finding exoplanets isn't easy. They're tiny and lost in the blinding glare of their stars. So, how do we find them? We use light. The transit method, used by NASA's Kepler and TESS telescopes, detects tiny dips in starlight as a planet passes in front of its star. The radial velocity method measures the star's subtle wobble caused by the planet's gravity. And now, with the James Webb Space Telescope, we can do something incredible. We can study their atmospheres. By splitting the starlight that passes through an exoplanet's atmosphere, Webb can identify molecules, water vapor, methane, carbon dioxide, even potential signs of life. Each chemical fingerprint tells us something about that world, what it's made of, how it formed, and maybe whether it could support life. Promising worlds. Among thousands of discoveries, a few stand out. Worlds that have captured scientists' attention and imagination. K2-18b, about 120 light-years away. It's larger than Earth, but smaller than Neptune. Webb's data revealed traces of carbon-bearing molecules, and possibly dimethyl sulfide, a chemical produced by life on Earth. It's not proof, but it's the closest we've come. TRAPPIST. One system, 7 rocky planets orbiting a small red dwarf. 3 of them sit in the habitable zone. Imagine, 3 Earths, side by side, orbiting one faint red sun. LHS-1140b. A potential ocean world, covered entirely in water under a thick atmosphere. And then there's Kepler 452b, sometimes called Earth's cousin. It's 60% larger than our planet, orbits a star much like the Sun, and might have mountains, clouds, and continents. Each of these worlds offers a new perspective, a new what if. New missions, new eyes. The golden age of exoplanet discovery is just beginning. ESA's Plato mission, launching soon, will search for Earth-like worlds around sun-like stars with unprecedented precision. Ariel will study hundreds of exoplanet atmospheres, decoding their chemical fingerprints. Future concepts like LUVOIR and HABEX could directly image other Earths, not just dots of light, but blue worlds with clouds, continents, and maybe life. Imagine seeing a real photograph of another Earth, oceans glimmering in alien sunlight. That's the dream scientists are working toward. What does life really mean? But when we say life, what do we really mean? Are we looking for creatures like us? Or just the simplest microbe? Here on Earth, life thrives in the strangest places. In boiling acid pools, beneath frozen glaciers, even miles underground. So, if life can survive here, it could exist almost anywhere. Maybe beneath the ice of distant moons. Maybe in the clouds of alien worlds. Maybe in forms we can't even imagine. What finding life would mean. The search for exoplanets isn't just about science, it's about perspective. Each discovery reminds us that our world is one of billions, a small, fragile oasis in an endless cosmic ocean. If we ever find proof of life beyond Earth, it won't just change astronomy, it will change us, because in that moment we'll know we were never alone. Signs of life, how we'll know. So, how will we actually know if life exists out there? How can we tell from hundreds of light years away? The answer is hidden in light itself. Every planet reflects and absorbs starlight differently. When that light passes through a planet's atmosphere, it carries clues, fingerprints of the gases within. On Earth, our atmosphere is filled with oxygen, nitrogen, and traces of methane, all produced by living organisms. So, if we ever find another world with a similar chemical mix, it could mean we're not alone. But it's not that simple. Life could be completely different elsewhere, using chemistry we've never seen. That's why scientists are now building AI models that can recognize biosignatures, subtle patterns that might hint at biology, even if it doesn't look like ours. In the near future, telescopes like LUVOIR might even take direct images of alien skies, showing the colors of sunsets on another world, and maybe the faint glimmer of something living beneath them. The future of humanity among the stars. Our search for exoplanets isn't just curiosity, it's preparation. Every world we discover teaches us more about how fragile our own planet is, and how rare the right conditions for life can be. Maybe one day humanity will leave Earth, not to escape it, but to expand our story among the stars, to build a second home under another sun, to explore, not as conquerors, but as explorers of the unknown. Projects like Starshot and interstellar probes are already being designed to reach nearby systems like Alpha Centauri, our first steps into the wider galaxy. If we can one day travel across light years, imagine what we might see. Cities beneath alien skies, forests of colors we've never dreamed of, and oceans reflecting a foreign sun. It may take centuries, but it starts now, with every telescope pointed toward the stars. If you enjoyed exploring the universe with us, don't forget to like, subscribe, and share this journey. The search for life has only just begun, and the next world we find might be the one that answers everything. Thanks for watching, and keep looking up.